Hello everyone. Welcome to Uncaught Exception Mini Session Episode 10. This mini session is a mini virtual version of our regular monthly meetups of software enthusiasts. This usually lasts for an hour with two speakers per session. So currently, we drag whomever we can convince to join us. So if you've got a tech you would like to talk about or learn something and would like to reinforce that learning by talking about it, build something and want others to know, or want to practice your public speaking and demo skills, or you just want to listen and learn to keep yourself updated on tech, we've got you covered. If you want to join us, just hit us up or slide into Arnelle Balane's DMs. And I think that's it for introduction. So let's start. So for this session, we're gonna talk about image formats for the web. And if we still got time, we will proceed to the introduction to Fast API. So our first speaker is Arnelle Balane.
Yes, hello everyone. Um, so what I'm going to share is about web formats for the web. I mean image formats for the web. So what's it going to be about? So you've probably heard of, probably familiar with different image formats, right? There's JPEGs and PNGs, which supports transparency, and then there's the more like optimized one, which is WebP. Um, it usually offers smaller file sizes while also supporting transparency or opacity or alpha channels. And so we're going to discuss a little bit about those, and also a new image format called AVIF or AVIF, I think. So we'll just compare each one of those and see like um, how to convert from like standard like JPEG um, images into WebP or AVIF, how to integrate it into build tools, and like see the differences in their file sizes and how to load them. Okay, without further ado, um, let's start. So to start, we'll take a look at a sample image, um, which is this one. So this will be our like baseline image file. So it's 2000 pixels wide. It's almost 1 megabyte in size. And yes, so this is a regular JPEG file. And yes, so usually load this in your HTML using an img tag. So, okay, so to start, let's start converting it into WebP. So to convert to WebP, there are basically different ways to do it. If you want to go like the very manual way, you can install the live WebP library from Google. You just download it from here, from the downloads repository, find your distro here. But after you install it, you basically get a cwebp command where you can pass in options like the quality and like the input image and the output image. So let's try that. Uh, so here's my image file. So cwebp-q. So the quality ranges for WebP and JPEGs. Quality ranges from 0, which is like the worst quality, to 100, which is the lossless quality. You keep the original quality. So you can just run this. And actually, I won't run this because based on experience, my laptop is very slow when I'm screen sharing. So I already ran this earlier. So um, here we see the result of that. WebP compared it to the original image, the original JPEG image with the same quality. WebP produces like a little bit more than half the size at 500 plus kilobytes, which is good. And now let's take a look at the next image format, which is AVIF. Um, to convert JPEG to AVIF, there's also, so AVIF is a pretty new image format, so there's not much tools for it currently. So there's a Golang library to convert images to AVIF. So to install it, you can, if you have Go installed on your machine, you can install it like this, or if you don't, which is like me, I don't have Golang installed, so you can download directly from the releases. So you just choose whichever makes sense for you, and then download it, and then you can run it right away. So in my case, I already downloaded it, so I now have the AVIF command. So I can pass in like the quality. So in AVIF, it's kind of different. The best quality is 0, and then 63 is the worst quality because image formats are that consistent. So let's try if -q. Let's try our lossless, or like the best quality, and then specify the input image and specify the output like file, and then after we run it, which I won't, we see that it generates the image.avif file, which is still smaller than the JPEG input, but not that much. So, and as we see, if in this case is larger than WebP. So why is that? So generally, so in this test, so AVIF, let's see, it has many options. It has like speed and stuff. In our case, we're just using the defaults here. CWebP also has a lot of options, and in our case, we're only modifying like the quality. So there are other factors here that might affect the file size, and also the best quality. Okay, the best quality image that WebP file might be comparable to like lower quality na AVIF file, which will have significantly smaller file size, and then the quality you can't tell the difference. So here we're using like the best quality possible for all of them. So these are the file size in our sample images. Another thing to point out between them is in WebP, and I've encountered this several times in the past. After you like optimize your images into WebP, it will sometimes, or like not, it's not very common, like rarely, it will happen. It can happen that the WebP image is larger than the original JPEG file, which is weird, but it happens. And whereas in AVIF, based on their, and they claim that they will always be smaller than the JPEG file, so that's nice. Okay, so that's basically how you convert JPEG into AVIF or WebP. So you can either use CWebP or the AVIF tool, which is the Golang like distribution. So that's nice. This is how you convert like one image at a time. So how about, so let's say you're building a site. Okay, before we get into that, let's try displaying the images. Image.jpg, image.webp, and then image.avif. So let's see. Here we see all of the images. So WebP is supported in, I think, Chrome and Firefox. And AVIF is currently, since it's pretty new, it's currently supported in Chrome, starting at Chrome 85. So here we see we're testing in Chrome. We see the JPEG file is being loaded. WebP and AVIF are being displayed properly, and they look pretty much the same. And okay, so how do we, like, for example, you're building a site. Obviously, you will have a lot of images. You don't necessarily want to convert each image one by one, right, in your site. So there are also other tools that can automate this process. One of them is ImageMin, or like image. I think it stands for image minification. I don't know. So ImageMin is available as a like its own standalone package, a Node.js package. You can also integrate it with Webpack and other bundlers if you want. So we'll just use it as a standalone package. So you just npm install it. Nope, not that. Image mean. So image mean is what you use by default. But if you want to include WebP support also, you have to install the image mean WebP plugin. So I already installed that. And then here, since we're using image main like the standalone npm package, we can write an npm, a Node.js script that will do the transformations for us. So we require image mean. Okay, this don't have to worry about the code. Um, Here we just specify that we want to transform the JPEG file and store it in the image mean folder. And then first we want a JPEG output with quality 80. So this is how you can like reduce the quality of your images. So generally, most of the time you don't really need like the full quality JPEG or WebP or AVIF file, because at lower qualities, for example, with JPEG around 80, 85, you can't really tell like the difference in the quality, or if there's a difference, it doesn't really like affect that image very much negatively. So lowering the quality a little bit saves you a lot of like bytes in terms of file size, while the quality remains pretty much the same to like the untrained eye or something. So quality advisable to reduce it to acceptable like values. And here we're doing the same for WebP. We're loading the same image. If in this example, we're just showing like one image, but you can pass in like globs. So for example, you can do like images slash all the images, all the JPEG files inside the images folder. You can do that, and then image mean will do transformations for each of those images. So here again, we pass in the quality. So let's try to run it. Oops. And here we have our JPEG file, still the same dimensions, but now from almost 1 MB after we transform it to, or like compress it to like 80% its quality, it's now significantly smaller at 125 kilobytes, which is like a huge savings in file size, and we can't even tell like that there's a difference in like the quality. So that's good. Oops. Same for the WebP image, same dimensions, but it's now 82 kilobytes. It still looks the same, at least to me. So that's nice. Unfortunately, as of now, there's no um, image mean support or plugin for AVIF yet, because as I said, it's pretty new. But there's already, let me see if I can find it here. So like around a week ago, it's already in their like issue tracker, so support should be coming sometime soon. Okay, um, let's compare them more. Actually, what I did, I tried to like compress all of the images in JPEG, WebP, and AVF at all like supported qualities. So here, let's see JPEG. See, here I have a version of the image at starting at 0 quality to 100 quality. Same for WebP, starting from 0 to 100, and same for AVIF. Just so I can compare like the how like the file sizes and like the image quality of each like level of compression or like quality. So 0 here, 0 is the best for AVIF. So let's for a start, let's look at like the worst quality for all the image formats. So let's start with JPEG. So 000 is the worst. WebP 00 is the worst. And for AVIF, 63 is the worst. So let's try to load that. This is what it looks like. So as you see, JPEG is, you can't even tell what's in the image. WebP shows a decent image with some like pixelized parts, but it's, you can tell that it's a spider, so that's good. Same for AVIF, although the pixelization, whatever, is, I think, kind of worse, at least for me. But if you compare the file sizes, JPEG is at 12 kilobytes, and this is one case where WebP gets bigger than the original image, but yeah, it's still small. And if you look at AVIF, it's just 3 kilobytes, so that's like 1/4 the JPEG version, so that's nice. Let's look at like slightly better quality. So actually, let's compare with like, let's compare the quality if both formats have around the same file size. I think that might be a fair comparison. I'm not sure. So let's look at JPEG. Let's choose a file size. Let's say, uh, where's the, where's the file size? Let's look at maybe like 50. Okay, if there's a 50, okay. So 50. Let's compare the 50 kilobyte versions of all the images. So for JPEG, that's the 040 file. Okay, let's use that. 040. For WebP, what's the 50 kilobyte version in WebP? 58. Okay, 58. And then for AVIF, where's the 50 kilobyte version? Okay, yay, there's a 50. So AVIF 23. So 23. So here we try to compare like the when all the images have the same file size and how much quality they can offer. So for JPEG, it's this one. It's not that bad, but you can tell like that it's not like the full quality also. And for WebP and AVIF, it's pretty much good, at least for me. I'm not like a professional at comparing images, so that's a disclaimer. So I think what we can do is, even if we keep lowering the quality of, let's say, AVIF here, we will still get like a similar result to this one, to like the 50 kilobyte versions of WebP. So let's try that like quickly. Let's go maybe 27, just a guess. So here, the 27, which is slightly worse version, has smaller file size, but quality is still maybe the same or almost worse. So let's just stay there. So yeah, so those are like the two image formats, WebP and AVIF, which is AVIF can be significantly smaller than both of them. And okay, so now we know, okay, which image formats to use, or WebP or AVIF, and how to convert like our input images from JPEG to WebP or AVIF, and how do we, like, for example, how do we like use it in, like, in production or like in actual sites? So you can either use the image mean. If you're For now, if you support WebP, then you can use image mean. You can integrate it with your like Webpack like builds or whatever bundler you're using, or you can also use like a image service um, like Cloudinary. So Cloudinary is an image service. Basically, it hosts images, and then it serves images in different formats and qualities. So let's take a look. So how to use Cloudinary image format. So here I uploaded my. This is the same. This is the original image that we have. The almost 1 megabyte image. Yes. So to use Cloudinary, just access it through a URL, and then So the URL format is basically like this. So res.cloudinary, then your username or like, yeah, your Cloudinary username, and then fetch, and then pass in the URL to the image. So this will access like the image through the Cloudinary um, service. You can do things like you can resize the image like on the fly, for example. One nice thing with this is you can um, control the image format when you request the image. For example, I want to force a JPEG image. Oops, it's not JPEG, it's JPG. So it will give you a JPEG image, or if you want to control if you want to get a WebP image, you can just pass in WebP. Let's prove that it's actually a WebP image. Here, you see content type is image WebP, so that's nice. And finally, for AVIF, surprisingly, Cloudinary supports AVIF, but it seems to be undocumented. So they might remove it or they might keep it, who knows. But right now it's supported. Um, Here it's yes, it's AVIF. Check the content type. It's image AVIF. That's nice. So let's compare all the three images by loading all of them like at once. AVIF. Let me load like the WebP image also. So and finally JPG. So yeah, I have auto formatter apparently. Let's see, localhost. So we see first one is JPEG, then WebP, then AVIF. They look pretty much the same. And if you compare the file sizes, JPEG is the same original size. WebP is 123 kilobytes, and this is the AVIF. Yes, so the AVIF file is just 39 kilobytes, which is cool. And then let's try if it improves a little bit. Yeah, you see in AVIF there's some like weird compression things. I don't know, but it still looks good. And yes, so that's one way up. So why would you use Cloudinary? It's very like convenient. So as you can see, just modify the URL, you get different file formats. Although the downside is that it only has like a free tier. You have to pay if you have high usage. And if you don't want that, you can always stick with like the image mean plus Webpack or module bundler na setup and then deploy everything. What else? And yes, I think that's it. AVIF, WebP, they're like the new image. I mean, WebP is not that new anymore, but AVIF is new. Um, and there's actually one more thing. How do you actually, let's say we want to display one image, but we want to display like the most optimal image that we can, right? For example, if the browser supports AVIF, then we want to display AVIF. Otherwise, try to display WebP and then fall back to JPEG. So in that case, we can use like the picture element in HTML. So basically, use a picture tag, and then there's a source. Source is set. Here you provide the URL, and then you provide a type. So for example, in this case, if the browser supports AVIF, then it will use the URL you provide here. Or if browser supports WebP, then it will use the URL that we provide here. And finally, as a fallback, just the default JPEG. So let's try that. Let's try the default JPEG first. And then this is the WebP. Okay, so WebP. And finally, AVIF. And okay, here. So this is how you like load different format images, whichever is like supported in the browser. It's the order here matters. So for example, in Chrome supports both of these, but the first one defined will be used. So let's see. So here I'm loading the AVIF image because Chrome supports it. Let's try in Firefox. So Firefox doesn't support the AVIF yet, but it supports WebP, hopefully. And where's Firefox? Okay, here. Hello, Firefox. So it's loading the image, and if you look at the network tab, it's loading the WebP image, so that's nice. Finally, Safari. Let's use Safari to test not having support for those, both for both WebP and AVIF. Where's okay? Paste. So as you see, you still see an image being loaded, although this time it's loading. How do you check here? Um, okay, I don't know. How do you check the? Wait, let me enlarge, refresh, check. So here you see that the content type is the JPEG image because Safari doesn't support both AVIF and WebP. So this is how you support like different browsers regardless of the different image formats that they support. So you just use the picture tag and the source and source elements specifying the type and then the different URLs. And that's pretty much it. Last thing you do promise. So one last thing, there are also other image formats, but they're very specific or like to like IE or Safari. So there's like JPEG XR or JPEG 2000. I've never used them. I've just read about them, but one of them is only available for IE. One of them is only available for Safari browsers, but they also offer like smaller file sizes. So if you want to check those, and if you like need support for like optimized images on those browsers, then you can maybe try to use those. And that's it for me. Thank you. I will stop sharing my screen.
So that's image formats for the web via all by Arnelle. So time for the audience to ask some questions. So any questions, guys? So the audience watching online, you can drop a comment so that we can address if you have any questions.
No
Wala.
question.
Wala. So I guess that was a good presentation. Wala may questions or the other way around, I don't know. So I think we still have time. So now we will proceed to introduction to Fast API by Emmanuel Lodovice.
Okay. So I guess I will share my screen now. Can you see my screen? uh, all right. I guess you can see my screen now. So tonight I plan to talk about Fast API. That's just a plan. I hope you will understand. So what is Fast API? Fast API is one of the new Python web frameworks, and there's so many, but this one is getting a lot of attention because of its really good performance. And as said in their website, the performance is even comparable to Node.js or even with Go. So, and then it uses Pydantic, uh, which is a data validation library that uses Python 3's new feature called type annotations. So very interesting. And then it is built on top of Starlet. So Starlet is a new ASGI framework or tool built for high performance async IO services. So async IO is like new in Python 3 as well. ASJI is basically a new upgraded version of WSJI. WSJI is Web Server Gateway Interface, wherein you just have like a function, you provide it with a request object, and then it should have a response in return. WSJI has been around for a very long time, and that's what like Unicorn uh, provides. And then, but the problem with WSJI is that it does not support newer protocols like WebSocket. So now the ASJ has been introduced to support newer protocols that requires longer HTTP connections. So that's what Starlet is. And then, so as I've said, Fast API is really fast, comparable with Node.js and Go. And then that's thanks to Starlet. Uh, and then it introduces hope to reduce human errors, developer errors, thanks to Pydantic and type annotations. Um, it's allows developers to code like relatively faster as compared to other frameworks because of Fast API utilizes type annotations. So your IntelliSense in your code editor is able to pick up new suggestions really quickly and more accurately, and many more. So you can read their documentation. So let's get right into it. How do you run it? How do you get started? So first, you just have to pip install Fast API, and then you also need to so you need to when you install Fast API, it will install Starlet and Pydantic automatically. But you also need an ASVI server. The one suggested by the documentation is Uvicorn. So once you have those installed, you could start your code. Uh, Basically, what you need to do is just I won't be live coding because there's too much code. I'm sorry. I'll just explain line by line. Uh, so first, you'll need to import Fast API, similar to how you do it in Flask, and then you instantiate a new app, an instance of the Fast API class, and then using the app.get or app.post decorators, you pass in the path, and then you provide a function that will handle requests to this path. So, for example, we have here on our root path, our function is called readroot, and then we just return dict, which is with key hello and value world. So once you have this, so for example, let's just comment everything out just to make sure that, oh my god. Okay, so let's assume that is all that we have at the moment. So to run it, you just need to run it through Uvicorn. So Uvicorn, the name of the file. So we have main.py and then app, which is the variable that you have there for the fast API instance. And then dash reload just makes it so that when you change this code, the server restarts as well. So we can go to there, and then so here are in our root path, we have a JSON hello slash hello world, and then so Fast API has a Swagger integration. So if you go to slash docs, it will display um, your Swagger docs. As you can see, we only have one right now slash root. So that's it. You have Fast API running. So now let's try to introduce a new um, endpoint called slash items slash item ID. So what's interesting about Fast API is that in your path, you specify the variable, and then it will be passed as an argument to your function. and then it will use the type annotation that you have on your function to determine what is the expected type of this path parameter. And then if you have, for example, on a get request, if you have like a new variable here in your function signature that is not part of the path, it is assumed that it is a get parameter. So let's try it out. So what we're doing here is we accept item ID, and then we accept query parameter Q, and then we just return it. So if we go back, we just save it and then refresh the page. UVcorn should automatically restart. So here in our docs, we have a new endpoint, slash items, item ID. And then you can click try it out. So it's expected that we pass in item ID. So C, it will know that it is an integer using the type annotation. So you get like 1. And then Q is a query string, 2. And then it will give us response of the correct response. Item ID 1, query string 2. So interesting approach on the URL management. The next is handling like put or post request wherein you have parameters on the request body. So here we have a new path item slash item ID slash dummy. So item ID is an int, dummy is also an int. But here we have this new parameter in our function called item that is not part of our path. So it is assumed that this item is going to be taken from the request body. So here we have an item of type item. So item is a subclass of base model, which is provided by Pydantic. So here we can specify like this class sort of defines the schema of the payload that we are expecting on that endpoint. So here we have a name, it has to be a string, a price, it has to be a float, and is offer, which is a boolean, but is optional. And we are defaulting it to none. So here in this endpoint, it is automatically identified by Fast API that the endpoint requires a JSON that follows this schema to be part of the request body. So if you save it and you go to the documentation page, refresh it. So we have a new endpoint as described by that function. And then it says it accepts an item ID, which is an integer, a dummy, which is also an integer. And then in the request body, it specifies that you need to pass in name, price, and this offer with these formats. So really cool. It's similar to what you do with, if you're familiar with Django REST framework, what the serializer class offers you. So, but here it's a lot simpler with Pydantic's base model. So we can try it out. So if you see 1, 2, then 3. And then in our payload, we just pass what's the default there. Waste time. So, yep, it's correct. We got the correct item name, item ID, dummy, price, 0. So, what if we don't pass in is offer? Execute again. Um, 1 sec. It's an invalid JSON, I think. So it still works because its offer is an optional field. But if we don't pass in price, you will have a very accurate error message saying that price is a required field. So we can just put them back. and then try it again. So everything works fine. But if you pass in something that's of a different data type than expected, so for example, for price, which is supposed to be a float, we pass in a string, and then we try it out. So here we see good error message again. The value should be a float. So, and we even have like red error there. So we pass in a string here, but the value can be typecasted to a float. If you try that out, that will just work fine. So you'll see it will get the 3.5 as a float. So that is it for the basics. If you wanna do like typically on if you're writing backend code, this is like not enough. Normally, for example, you want to check if like say for example, I want the price to be greater than one. So we could add a validation for that in our code. So we can say that if item um, uh, price is greater than uh, less than zero, we can raise. So here, the error management, we need to raise an HTTP exception. Can raise an HTTP exception, and this accepts a status code. So typically, validation errors are 400 or bad request. So we pass that there, and then, for example, the detail, we can specify that price, the value has to be greater than zero. So if we try this out, um, here we say we go with negative 5. Let's see if that works. We have our validation error. Again, it's a 400 response, and then the price has to be greater than zero. Cool. So maybe put it back, and then okay, it's a 200 again. So that's basic handling of request response. But this is not. This is all cool and all. I like it, but I'm more interested on the other things that Fast API can do. So out of the box, Fast API supports um, background tasks and WebSockets. So which isn't supported by web frameworks like Django, which is the one I'm using. So I'm interested in those features. So right now I'm working on this simple application called Stockdash. So here we have my app, but it doesn't work because what this app does is it just grabs historical data, stocks data from PSE, but the API and the API that I am using uh, is not run on HTTPS, HTTP. So I need to write a wrapper around this API that I can run over HTTPS. So I plan to do that using Fast API. So in my project right now, I have like this P6 file that just basically sends get request to the physics API endpoint, which is an HTTP endpoint, and then just gets the result, the raw JSON. It accepts like a stock code, start date, end date, and then a step like you want to get the stock value of every 5 days or whatnot, and then it will just loop over the dates in between the start and end date, and then get the stock price and then return it. But you could have like Say for example, within 1 year. So it would take like a long time to finish the to get all the data. So I plan to run this like in the background as a background task. So that's exactly what I did. So here I have like an endpoint called get price. Accept a stock code, start date and end date. And then here it's indicated that we are using background tasks. So which is an instance of background tasks. They're just imported from Fast API. So automatically, this will not be supplied from the URL. Fast APIs will supply it when processing the request. And then we then add a new task to the background task, which is our get stock price. This method, that's we're passing in the function name, and then all the arguments that this method expects: stock code, start date, end date, step, and key. So we have here stock code, start date, end date, step, and key. And then we just return right away what was the past parameter. So let's check it out. Uh, where is that? Okay, this one. So here, this is the endpoint. So basically, this is actually a new project from the previous one, but it's all just the same. The same setup. We just import plus API, the same way of running it. So here we have a stock code. Say for example, I wanna try LDT, and then from September 1 to let's say October 3. Step, just probably make it faster. One is fine. So I then run execute, and then the response is like instant. So we have here the parameters that we passed, and then the key. But if we look at our server, so here it's running the background. Okay, let's just refresh it because we can see. Uh, again. Uh, so we get the request, and then after a while, the background task is finished, and then it just prints out um, the data we got from physics uh, in here. So yes, we got the data, the historical stock value between these dates, but it's not part of the response that we get from this API endpoint. So this project is not yet finished. So what I plan to do is that using this key, I could like keep on retrying, like send a calling request to a new endpoint that I will make, providing this key until the value is available, or use WebSockets so that the backend can just then push this data to the front end using the key. So I am leaning towards the WebSocket implementation, but that is not yet done. Just to demo that Fast API supports WebSocket, we have a new page called chat. So Fast API is not only like a JSON-based API, it can also render HTML, of course. So uh, here we have the endpoint slash chat. We are sending in an HTML response. So here we are rendering an HTML template called chat.html, basic HTML. That connects to WebSocket URL there, and we are using Jinja templating. So here you can just import Jinja to templates. So it does not work right out of the box. You need to pip install Jinja to make this work. So just import Jinja to templates and then initialize a templates object specifying the directory where your templates are located. So in here, as you can see, templates, it's inside the templates directory. And then we just every request to this endpoint, we just send an HTTP HTML response with our chat template, passing in the request and some context variables if you are using any. So here I have a context variable called title. In the chat HTML, you also have like is being accessed right here. And then it is required that you pass in the request object as part of the context. So here you will notice that our chat function accepts a request argument, but this is populated by past API when processing the request, and it's not part of the URL. So as you can see, we have this page. So for WebSockets, we introduce also a new endpoint called /WS, which is a WebSocket endpoint. So it accepts a WebSocket object. Again, this is populated by Fast API automatically. And then we just wait for the connection. And then we wait for when we receive text from the WebSocket connection. And then when we receive a text, we just write it back. So, and then in our HTML, we have some JavaScript code that just connects to that WebSocket endpoint that we have defined. And then when this form is submitted, we just um, send the value of the input field, text field, to the WebSocket connection. And then on message, when we receive a message from the WebSocket connection, we just append it to our DOM. So notice that we did not, upon submitting the form, we are not writing the value of the input to the DOM. It's only when we receive data from the WebSocket connection. So that is that. So it works. You look at here. Wait, I'm not sure where you get the response, but somewhere here, messages. Okay, here. So we are getting messages from the WebSocket connection. So WebSocket works, but this is hardly a chat because if you open two tabs, send a message here, it doesn't appear in the other one because in our WebSocket endpoint, we are writing the text to the same socket connection that sent it. So we have when you have two tabs, these are two different socket connections. So basically, we are not writing to both connections. We could write a quick fix if we want. So we can just do sockets equals that. And then whenever we have a new connection, we can just do sockets that append WebSocket. And then instead of writing to the same socket that sent the text, we can just for loop for socket in socket. We write there, and text. So this means that whenever there's a new socket connection, we add it in our list, and then whenever we receive a new text, we write it in all sockets, that socket connections that we have. So if we refresh this, test appears in both. Z. So that's WebSocket for you. Of course, you need to handle the disconnection and everything, but for demo's sake, this works. So that is that. So what I plan to do, though, this is maybe we can do it now. I think we have time. Well, let's just when you send a request to this get price endpoint, maybe we can pass in the sockets here, and then here, and then we can just for loop it. I have never tested this, but I think this works. And then we test right in the so we also need to specify this as an async function because we are using await. Let's see if this works. One, and then we send a request. So where is it? This one. Execute. What? It doesn't work. Okay, let's try again. I think that was because we are not handling the disconnections properly. Let's try again. Dun dun dun. All right, there we go. So we get the data from the stocks API. So this is what I plan to do. Of course, with better code, with better. So there a while ago happened because we sent we sent data to a socket connection that was already closed because I closed two of the tabs that was here. So that was causing the error. But basically, this is the point. Very interesting. Like that's fast API. The things that I like about it. Uh, Interesting things. So to sum up, let's look at what we saw again. So Fast API was built again on top of Starlet. It's super fast, comparable to Node.js and Go in terms of performance. And then for data management, handling data, validating data, it uses Pydantic. Pydantic is a validation framework that uses type annotations to specify, to check if the past data is of expected type. So, and then this is kind of sample ways of defining endpoints on your API. Uh, in your paths, you can specify arguments to the path, and then it gets passed as a argument to the function that handles the request to a specified path, and then it also looks at the type annotations that you specified on the function argument, and it will use that as the expected type of the data passed in the path. So if there's a variable that's not part of your path here, and then it is assumed that this is part of a query string. And on post request or those requests that you can specify the HTTP data content or the payload, such as post or put request. Again, we have our path, and then here we have an argument called item, which is not part of the path. So it is assumed that this item is going to be from the request data. And then when you have like custom validations, so for example, here we're checking that the price is greater than zero. You can just raise an HTTP exception specifying in the status code of the response object and then the payload. So what's interesting about this is in many like frameworks, when you are not here, you are raising an exception and not returning an HTTP response object, which means that if you have handy functions like the my test here, let's just and then if we move this entire thing here, so since because we are raising an exception here, this line of code is not run. So yeah, basically the difference between raising an exception and returning a value. So that's that. And then out of the box, also Fast API supports WebSockets and background tasks. So here we have a background task called get stock price, and that we just add to background tasks. And then when we receive a request to this endpoint, we schedule a task that is run on the background. And then we have a socket endpoint. Um, that allows for the client to connect uh, to make a WebSocket connection to this endpoint, and then our background job can then write to the socket connections. That's it. Thank you. If you have any questions, let me know.
Thanks, Daman.
Yeah, so that's it for introduction to Fast API by Emma. Whew, that hapit wa mo. But
Yes, I do
anyway,
have.
it's
Have
I
a
did
somehow
this
question.
a while ago.
it's okay. Time for questions. Questions, guys, go. Keep it pouring.
Yes, I have a
Yes,
question.
go question.
So does Fast API like have like built-in support for like I mean does Fast API come with like an ORM or built-in way of like communicating with databases and stuff?
No.
Okay.
So Fast API is like very small. If you actually pip install it, it's smaller than Starlet. That's like 48 KB, 49 KB. They're really small, but it has very good documentation. So if you look at here, in the Fast API documentation under I think advanced user guides, you will see like documentation on how to use like uh library or libraries like Piwi, or if you are not using Piwi, it also I think suggest SQL Alchemy somewhere here. Yep. So yeah, out of the box, it does not have an ORM unlike Django, but the good thing is that you can just use whatever ORM you want, like SQL Alchemy or Piwi, or
Okay.
maybe something else like SQL Object.
Okay, thank you.
Okay. By the way, the people who are watching this live can ask questions using the comments. So yeah, we can wait if you want. Ay mo kaulaw, guys.
Sorry if
Anyone
you
else?
sorry if you had trouble understanding. I was talking really fast. And
It's fine.
then
We can watch the video again later.
Yeah.
and very confusing terms like path and arguments and function signature, blah blah blah. But I hope triggered some interest on Fast API. I think it's cool. I hope you also think same way.
I have one more question.
Yep. Go.
Uh,
Go.
uh, so Fast API comes with like built-in support for running background tasks, but it's also possible to like use other like third-party services for managing and running tasks, right?
Yes,
Basically, or
it's yes. So I think it is documented somewhere here that if, say, for example, you are running like really intensive background tasks that like super mission critical and blah blah blah, then you probably should be using a more mature, more robust solution like Celery, wherein you have your message queue, and then when the server stops suddenly, then your background job is just not forgotten. So when you unlike like Celery, if Celery breaks or like your server stops, you can just start Celery, and the scheduled jobs are still there in the queue. Here, if you stop your server, your job is gone.
Okay, thank you. Yeah, I was more thinking more about like using Celery because since you can host Celery, I think on separate servers, I think so compared to having your task run on the same machine as your server, for example.
Yep, yeah, totally agree. But Celery is great, but it's also harder to set up. Like you don't just pip install Celery and you'll run Celery right away. You have to
That is
sudo
so
apt
true.
get sudo apt get I don't know Redis and RabbitMQ to get everything running. So it's great, but it's complicated as well for a reason. Any other questions?
Yep. Any other questions? I have no questions. I'm barely,
No
I
more
can't
from me, thank
multitask.
you.
Can't multitask. So anyway, I think that's it for this session then, guys and girls.
All
Wala pa
right.
Well, Ice.
Look,
Okay. So thanks everyone for joining, and of course, again, plug. Let's plug. If you're anyone, for those who are watching, if you're someone who have some tech you would like to talk about and and you learn something and you want to talk about it because yeah, you learned something new and you want to reinforce that learning, or you built something and you want others to know, you want to let us know, and or want to practice your public speaking or demo skills that you have before your talk or anything, or if you just want to listen or lurk to keep yourself updated, or you just want to talk to other people during this quarantine about tech, we are here, guys, to listen. So of course we have to comply to the YouTube format by saying please like and subscribe, but seriously though, like and subscribe, we need it. Anyways, we would love to hear some feedback too. So hanggang sa muli, that's it. Paalam!
thanks for watching.
Thanks everyone.